This is an interesting problem on free fall due to gravity. See, we know that when you drop a ball, then it falls down and then hits the ground. What do you mean by dropping a ball? By dropping a ball, we mean that the initial velocity is 0. We don't give any velocity, we just drop. Then the earth is pulling down the ball, pulling the ball down with a uniform acceleration g. Right? Now suppose you do the same experiment on, say, moon. The ball is dropped on the moon from a height of 1.4 meters. Okay? So we are given that this distance is 1.4 meters. Right? Ball is stopped. And you are given that the acceleration due to gravity on the moon is given to be 1.67 meters per second square. So the acceleration on the of gravity on the moon right, and ball is dropped, that means the initial velocity is 0 and the distance s is, let me write, minus 1.40 to indicate that it is falling down, okay, and the acceleration is minus 1.67, so this is meters per second square. Now, what is the question asked? The question asked is, determine the time for the ball to reach the surface of the moon. So to find the time t for the ball to reach the surface of the moon. Right? Okay. So if we want to find t, so again we can use the same kinematic equation. So S equal to P naught t plus half a t square. Now substituting the values here, this is minus 1.40, is that right? And 0 times t, so we don't have to bother, V naught is 0, and then acceleration is negative, so minus half 1.67 t square. So we can cancel the negative sign on both sides. So we get 2 times 1.40. So 2.80 equals 1.67 times t square. Am I right? So this gives me t square equals 2.80 by 1.67. So when you calculate, you get it as, so up to 2 digit decimals, it is 1.68. Right? And then the square root. This gives t equals square root of this. So going back to the problem, see, a ball is dropped from a height of say 1.4 meters on on the moon, and it falls and hits the surface of the moon. Now you are given how does it fall when you drop it? It is because of the gravitational force, and the acceleration due to gravity on the moon is given to be minus 1.67, actually 1.67 meters per second square. It's falling down, so because of the direction, I have taken it as a minus 1.67 meters per second square. The question is how much time it takes to touch the surface. So look at the equation s equal to v naught t plus half at square. You are given the distance and the initial velocity and also the acceleration. So you are dropping the ball, so the initial velocity is 0, and so you get 1.40 equals half of 1.67 t square. So cross multiplying it 2 times, so 2.80 is 1.67 t square. So calculating, and for t square I take the square root, you get 1.29 seconds. So it means that if you drop a ball from a height of 1.4 meters on the moon, it hits the surface of the moon in 1.29 seconds.
Thank you for watching. Visit us at needbook.in.